Hello fellow students, once again, my name is Andrew Keister and my partner is Gregory McAdams. Today we'll be demoing our location tracking app in two videos. The first video will describe the features and the second will demo the tracking capability. So I'm going to go ahead and start up the app. On startup, the user is greeted with a toast welcome to the app, and we start out with the world view, and once the GPS unit gets a fix, it will zoom into the user's location and add a marker to the map. Okay, so we see that the marker was added. As the user moves, this marker will move based on the tracking algorithm, and a polyline will be displayed tracking the user's progress. Tapping on the marker will clear the polyline for the current tracked path. So, I mean, if I tap on this now, it doesn't do anything, but if we actually had a path from that track the user's location, then tapping on it would clear it. In the top right corner, there are 4 overlay windows that display the bearing, step count, latitude, and longitude. These overlays will update as the app tracks the user's movement. We've also implemented an options menu, which allows users to select among the 4 map types provided by Google based on his or her preference. So I'll go ahead and demo that. Satellite, hybrid, terrain, and I'll go back to the road map. Zoom back in. The tracking algorithm that we used is based on taking GPS measurements every 2 minutes and then using a DR calculation every 5 seconds to track the user location in between measurements. The DR calculation we used was based on Haversine equations. These equations can be used to calculate a new latitude and longitude given the original latitude and longitude, bearing, and distance traveled. For the bearing calculation, we used the accelerometer and magnetic field sensors along with the gate rotation matrix method. Low-pass filters were used to smooth the data. For tracking the distance traveled, we initially explored using linear acceleration, but quickly determined that there was too much error in this approach. Instead, we tracked the number of steps taken in a 5-second window and then multiplied by an empirically determined meters per step to get the distance traveled. Using this information, a new lat long point was found. Timing in the DR app is controlled via handlers. The GPS timer re-enables the GPS to take measurements, and the DR timer sets a flag indicating when a new position should be calculated via the device sensors. We use another handler to update the map with the lat long point from the GPS or the DR algorithm. So, probably during the course of this video, you've seen these messages pop up at the bottom of the screen. The one that just popped up was the GPS timer firing. Okay, so you see the GPS unit is getting a new fix. Slightly inaccurate fix, but still pretty close. And these other ones are indicating when the DR algorithm is being run. So if I was actually out and moving around, it would actually track the user's location. So if I click on this marker, you'll see that it clears the line. So that's pretty much it for our first video. We hope you enjoyed our feature description. Our second video will demo the app in action.